Hello students, Professor Benavides here. Let's talk about part 3 of chapter 4. Chapter 4, as you remember, is called Working with Lists, and we're going to go ahead and drill down on parts of a list, tuples, and styling your code. So let's start off with the cheat sheet. I like to start off with that. So let me go ahead and download that and show that to you. And here it is right here. Okay, so we're going to be zeroing in on slices. Let's see where that is on here. Last time we covered the range function, simple statistics, slicing. Here it is. So slicing a list is when you're working with parts of the list. So it gives you some really good simple examples here. We'll also cover copying the list. List comprehensions were in the previous one. And then we'll talk about styling. And the styling are just some recommended ways of typing in your code recommended by PEP8. And I believe PEP8 was started by the founder of Python, Guido. And it's being maintained by other people. So let's get right to the chapter then. So here we go. Let's look at the first example here. It's called slicing a list. But I guess before we do that, let's talk a little bit more about where we've been and where we're going. Okay, so we've been talking about, working with lists. So in chapter 3, you learned how to access single elements in a list. And this chapter, you've been learning how to work through all the elements in the list. That is, looping through them. Okay? So we're also going to learn how to work with a specific group of items in a list, which Python calls a slice. So slicing a list, to make a list, or to make a slice, you specify the index of the first and last elements you want to work with. As with the range function, Python stops one item before the second index that you specify. So in other words, it goes up to that index, but does not include that index. Let's look at an example here, and go ahead and make this a little bit bigger here so you can see it better. So I've added a lot of documentation on here. Line 3, I go ahead and define my list. And this list is called players. And it's got 1, 2, 3, 4, 5 elements in it. And the first element is at index 0. So line 4, we print out the players that start at index 0, go all the way up to index 3, but don't include 3. So that would be index 0, 1, and 2. That gives us Charles, Martina, and Michael. Next example on here, players 1:4 generates a subset of the list. And it starts at index 1, which would be Martina, and it goes all the way to 4, but doesn't include 4. So that would be Martina, Michael, and Florence. So as you can see here, we've got 5 elements. So the largest index in an element that they have, it's kind of like arrays. If you ever covered arrays in other languages, the largest index value is 1 minus the number of elements in the array, right? This author doesn't cover it that way, but that's the way it's covered in most other programming books. The line of code on line 6 is kind of interesting. Is when you don't specify the first index, it starts at the very beginning. So if you omit the first index, it starts at the beginning. It goes all the way to 4, but doesn't include 4. So that gives us Charles all the way to Florence, right? And then the next one on here, this one's kind of neat. It's kind of like the opposite of what we saw on 6. So on line 7, it says 2 colon. It doesn't give us the ending. So what does that do? It goes all the way to the end. So we're going to start at index 2, which would give us, let's say Charles is at 0, Martina's at 1, Michael's at 2. So we're going to go Michael, Florence, and Ellie. Now, this one's really interesting. The negative value. It's going to start at a negative value. It's going to go all the way to the end. So the last one on here is -1. Second one, the last is -2. Then we have -3. So it would be actually the same as what we had before, right? And then the last one on here provides for a skip value. So it starts, in this particular case, I'm saying starting at the first one, going all the way to 5, but you're skipping every other one. So it can take, when you're slicing, it can take 3 indexes. So the first index is where you start. The middle index is where you go up to, but doesn't include that. And then the third value is a skip. So I get, since I'm starting at 0, I would get Charles, and then Michael, and then Ellie, because I'm skipping Martina and Florence. Okay. So that is slicing a list. Now we can also loop through the list. You can use a slice in a for loop if you want to loop through a subset of the elements in a list. Let's take a quick look at that in players. The next one on here. I'm going to go ahead and run this. And I just threw in a couple of little ideas while I was doing this. We have our list defined on line 3. And I just say, here are the first 3 players on my team. I'll loop through that. That would be Charles, Martina, and Michael. So I start with nothing on there. So it's blank colon 3. That goes all the way to 2, right? So it's 0, 1, 2. That gives me the first 3. So that prints Charles, Martina, Michael. Then I just played around with, instead of a list of names, I created a list of numbers here, and I did a step on it. So I started at the first element, and I go all the way to the end, and I'm skipping 1. So that would give me the odd numbers and the even numbers. See how I guess it'd be? There's a cute little way of using that skip on here. Okay. So now that brings us to the topic of copying a list. And the correct way to copy a list is to use the colon here with nothing before it and nothing after it. So to copy a list, you can make a slice that includes the entire original list by omitting the first index and the second index. This tells Python to make a slice that starts at the first item and ends on the last item, producing a copy of the entire list. Let me go ahead and run that. So here we see that my list is defined on line 3, and then I copy it. So I say my foods, and I put in that colon, and I copy it and send a copy to friends_foods. Okay, so now I print out the contents of my foods and the contents of my friends. At this point in time, they're equivalent. What we want to do is just take this up. We want to go ahead and take this up a notch so that we can go ahead and verify that they are separate. We'll do that in just a minute. But to create the copy, remember the correct syntax. This is a copy, so you're going to end up with, you want to create 2 separate lists. Okay? This next example over here is, proving that they are 2 separate lists. Okay? In this particular case, we see that I've got my list defined on line 3. I copy it the right way with the colon, and I append cannoli to my foods, and I append ice cream to the other one. And now I'm going to prove that they're separate. Let me go ahead and do a control B here, and notice that I have two separate lists, and that is what I wanted to go ahead and do. Okay. Next example on here is something to look out for. It's something to look out for because it's easy to forget the correct way to create a copy. That is with the colon. See, in this case here, I just used the equal sign on line 6. And when you do that, now both variables point to the same list. So you didn't make a copy to create two separate lists. You're making one equal to the other, so they're pointing to the same list. So when I append cannoli and then I append ice cream, on here, let's see what happens. When I do that, then both cannoli and ice cream are added to both lists. So in other words, they're pointing to the same list. Something to look out for. Okay. Now that brings us to the try it's. Try it yourselves, which are very good examples. Example 4.10 called slices. Using one of the programs that you wrote in this chapter, add several lines to the end of the program that does the following. Print a message for the first 3 items in the list. Yeah, I just saw an example like that. Then print a message for the middle 3 items and then the last 3 items. So that's kind of easy to do. This was the one that we already had. I know it was so I just copied the line 3 on here, and I let me go ahead and run it so we can see the output. So the first loop I have here gives me the first 3 items because it starts at the first one, goes all the way up to 3, but not including the third index, which would be index 2, right? And then we go from index 1 to 4, but not including 4, right? 1 to 3. So that would be the middle 3. Then the last 3, you could do this in different ways. You could actually specify the actual ones on here, but I'm starting with a -3. We start with -1 at the very end, -2 and -3, and I say go all the way to the end. So that gives me the last 3, which would be Michael, Florence, and Ellie. Pretty neat. Example 4.11. My pizzas, your pizzas. So you start with a program, with your program from exercise 4.1, and it says make a copy of the pizza and call it Friends Pizza. Then do the following: add a new pizza to the original list, add a different pizza to the friends list. Prove that you have 2 separate lists. So this is very similar to what we just did before. Print a message to specify it. So let's see here on line 3, I go ahead and define my list. It's got pepperoni, Hawaiian, and veggie on there. And then I copy it the right way so I can create 2 lists. And that's done with just specifying the colon. In other words, the beginning and ending are not put in here. So then I append to pizzas, to favorite pizzas, the original one, if you want to call it that way, and friends pizzas, I append to that also, pesto. I like pesto. I like that one. Have you ever gone to Grimaldi's? And they have this great chicken pesto pizza there that I always get. But anyway, so I append these 2, and then I have a loop here where I loop through the original list, and then I loop through my friends list. So let's go ahead and run this, Control B. So I added meat lovers to mine, right? And to my friends, I added pesto. And there we have it. We've got 2 separate lists. So when you make a copy, it kind of gives you like a starting point, and then you can go ahead and add to each separate list. Example 4_11 or 4.11, try it yourself, called more loops. So it says all versions of foods.py in this section have avoided using loops when printing to save space. Choose a version of foods.py and write 2 loops to print each list of foods. So this one was kind of easy. And that's why some of these he doesn't do, because he thinks they're too easy for you, I think. I don't know. But that's what I'm wondering, why some of the solutions are not given online. So line 3, I define my pizzas, right? And then I go ahead and copy the list. Let me go ahead and run this so we can make sure we have the output at the bottom. And then I go ahead and loop through the through my list and loop through his list using a for loop. So as you remember, when we're using a for loop, we always specify the name of the list in plural, right? And then the temporary variable would be the singular version of this. I know you could just put X or I or whatever, but it's not good form. You want to do singular, plural, and do it that way. Okay. All right, so now we enter in a new topic, the topic of tuples. So Python refers to values that cannot be changed as immutable, and an immutable list is called a tuple or tuple. Depends on how you want to pronounce it. So as far as defining a tuple is concerned, a tuple looks just like a list, except you use parentheses instead of square brackets. Once you define a tuple, you can access individual elements by using each item's index, just as you would for a list. What happens if you try to change one of the items in a tuple? Well, guess what? You get an error because tuples are immutable. Okay, so let's go over a little bit of this code, and then we'll come and talk about it a little bit more. So I define my tuple on line 4. It's called dimensions, and we're going to say that this is a rectangle that we're not expecting to change during the life of the program. So we can access each element in the tuple by the same way we did with list, by using the square brackets. That gives us 250 when we access element 0 and element 1. We'll come back to this error in just a minute, and then I just compare that with a loop, looping through the tuple with a for loop. So for dimension, in dimensions, print dimension. So that gives me the same 2. Let's come back to the middle now. If I try to assign 250 to dimensions of 0, it's going to choke. And let me go ahead and prove that to you. Which, you know, this, you could do this in a list, you know. So let me go ahead and run this. And so there we go. We've got a type error, and it says, you know, if you want to follow the trace back, it says line 11. So line 11 is where this happened. It says type error. Tuple object does not support item assignment. When you're trying to do an assignment here, and it's saying, you know what, it doesn't support it. Can't do it. You know, so I'm going to do a control minus. I make this a little bit smaller so I can get rid of the little X, and then make it big again. Okay, and I'm going to comment the offending code out again. I just have that there for demonstration purposes on here. So note that tuples are technically defined by the presence of a comma. The parenthesis makes them look neater and more readable. Okay. So as far as looping through the values in a tuple, I just finished giving you an example of that. So you can loop as well as access each one individually, as we did with the list. As far as writing over a tuple is concerned, although you can't modify a tuple like we did on line 11 here, you can't do that. You can assign a new value to a variable that represents a tuple. So if we wanted to change our dimension, we could redefine the entire tuple. So let's go ahead and take a look at that over here. So here's my original tuple on line 5. And what I end up doing is just defining it again with the same name. That's how we can associate a new tuple with the variable dimension. And let me go ahead and run that. So as you can see, the original dimensions were 250, and now it's 400 and 100. But you can say they weren't really modified. You just went ahead and rewrote or overwrote, you wrote over the tuple and created another variable. Okay. So why use tuples? When compared with lists, tuples, they're simple data structures, yes, but we use them when you want to store a set of values that should not be changed throughout the life of a program. So we'll find more reasons to use this later on. So that comes to, we come to try it yourself, number 13. And let me go ahead and run that real fast. And in this one, we have a buffet, and we've got some food on here, and we loop through it, and then we're gonna, let's see what we're gonna do here. Try to modify one. Well, you already know it's gonna choke, but we're gonna change the menu, and that means you're gonna have to replace the item. And then, okay, so let's go ahead and look at this. So here's the original one. Here's my menu. Rockfish sandwich, halibut, whatever, smoked salmon, chowder, crab cakes. I think crab cakes would be the only ones I would like if they're real. I don't like fake crab. If you ever had the real thing, Okay. But anyway, here's my original tuple, and I go ahead and show it, right? So now what I'm doing here is I'm overriding it, and I'm adding king crab legs. All right. So now we have an update to the menu. Okay, let me go ahead and run that. So you can go ahead and see that the menu has changed. So you can't really do assignment statements on here. That if I try to do an assignment statement, it's going to choke. Where did we do that before? We did that in one of these other ones, right? Here, right? So in this one, I tried to do an assignment statement. It choked. If I try to do that here, menu items, gets, and I try to put in, something very similar to that, maybe a different menu item, it's not going to work. The only way to make it work is to go ahead and redefine the entire tuple again one more time with the new items that you want. Okay. Well, that, my friends, is the end of this last section of this chapter. This chapter really included a lot of interesting things. It finishes up with a topic of styling your code. And so the idea here is that Python programmers have agreed on a number of styling conventions to ensure that everyone's code is structured in roughly the same way. So we're going to be studying about PEP8, and I think, my memory serves me correctly, I think Guido started this, and then others have taken over. So if you're hoping to become a professional programmer at some point, you should begin following these guidelines as soon as possible to develop good habits. So the idea is this: you want to be writing your Python code according to these Python conventions. If you write your code in a Java style or a C++ style or a Pascal style or whatever, it's not going to go over really good with the community, okay? So pay attention to this. We start off in this section talking about the style guide. We're referring to the Python Enhancement Proposal, PEP. Okay, so when someone wants to make a change to the Python language, they write a Python Enhancement Proposal. One of the oldest is PEP8, which instructs Python programmers on how to style their code. So it has to do with styling. PEP 8 is fairly lengthy, but most of it relates to more complex coding structures that we've seen in our class so far. So given the choice between writing code that's easier to write or code that's easier to read, Python programmers will almost always encourage you to write code that's easier to read. Now, isn't that subject to interpretation, right? I think advanced programmers will typically have a different idea as to what they think is easier to read. But anyway, let's go along with the idea here, right? So the following guidelines will help you write clear code from the start. So as far as indentation is concerned, PEP 8 recommends that you use 4 spaces per indentation level. So you should definitely use your tab key, but also make sure your editor is set to insert spaces rather than tabs into your document. So you do this, your author shows you how to do this in Appendix B. I've already done mine, so I don't have to bother with this anymore. Mixing tabs and spaces in your file can cause problems that are very difficult to diagnose. If you think you have a mix of tabs and spaces, you can convert all tabs to a file of spaces in most editors. Line length. So PEP 8 the PEP 8 guidelines for line length are not set in stone. I think historically we've been going for a single line being 79 characters, comments being 72, but that's still being discussed. So most editors allow you to set up a visual clue. If you refer to Appendix B, you'll learn how to do that with Sublime, the Sublime. And when I said that I set my tab or I set it to spaces, I was talking about my Sublime text editor, because that's what Appendix B in your book covers, is the Sublime text editor. It talks about how to go ahead and do these modifications so that you don't have to be manually doing that. So he shows you how to set your line length and all that, and you don't want to, I know that there's different monitors and you can have different lengths of code, but it makes it harder when you have one line of code that just goes on forever, So you definitely, if you're going to be opening up several files, and it's not uncommon for advanced programmer to open up 3 to 4 files at one time, and it's difficult to see all the code if you're having to go left to right, left to right, left to right, when you could just see it, in a more condensed kind of way. So these are the kinds of conventions or guidelines that, if we want to be a Python programmer, we should conform to. Also, blank lines. So the idea is that blank lines don't affect how your code runs, but basically, if you have a section of code and then another section of code, put one blank line in between them. But you can go overboard on this. Don't go overboard. Don't have like 4 blank lines and then a section, and then 4 blank lines and then a section. So too much blank lines is bad too. Okay. Other styling guidelines. PEP 8 has many additional styling recommendations. Most of the guidelines refer to more complex structures that we haven't written yet. So he refers you to go ahead and explore that. The try it yourself on 4.14 has you go to the original PEP 8 and look at it, and then the try it yourself 4.15 talks about making some of these changes in your code. But like, say for example, using 4 spaces for each indentation level, and using less than 80 characters for each line, and not using blank lines excessively. But guess what? If you've already set up your editor, and if you've already read Appendix B out of your book, and you've set your editor, Sublime, to deal with these issues, then you don't need to be worrying about them anymore. Okay, well, that's really the end of this chapter. We talked about really working with lists more effectively and efficiently. We learned, we learned how to loop through them. We learned about proper indentation. We learned about numeric lists, how to slice lists. We learned about tuples. Next chapter, chapter 5. We're going to go ahead and learn about if statements. We'll also learn about the, conditional tests and many other interesting things as well. So until later, my friends, happy coding.